we're almost done proving the fundamental theorem calculus part 1. The integral from f of f from a to b is just evaluate the antiderivative of b and subtract the antiderivative of a. And we've set it all up, so now it's time to just kind of figure out what's going on here. So I have that the sum of all these big f's are always equal to f of b minus f of a. But these f's, I know, these f's I can replace with a little f, blah, 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 right? Times this interval, length of this interval. So this is equal to the sum of little f of ti times xi plus 1 minus xi. Right? These are equal. And so maybe I'll even write this in red. And these are always equal to f of b minus f of a. Why is that? Because that's equal to that, and that's equal to that. That's kind of the telescoping sum where you get all this cancellation. But notice that, again, if you ignore this red part here, on the interval, f of ti between xi plus 1 minus xi is got to be less than or equal to the infimum of little f on that interval, which we can write down as mi, I plus 1 minus xi. And it's got to be less than or equal to, I'll write it over here, less than or equal to the sum of the infimum. Right? This is, right, because it's always going to be true that f of ti is less than or equal to the biggest thing of f, little f, and the smallest thing of little f. This is the imp of f of x on the interval, and this is the sup of f of x on the interval. That just has to be true. And so that's what the mean value theorem gets us. This allows us to take these capital F's and compare them to the infimum of little f and the infimum, or in the supremum of little f. But this thing is equal to L of f for that particular partition. That's less than or equal to this thing, but who cares about that thing? I'm gonna write it as what is equal to f of b minus f of a. So I got the black inequality here, but now I can just replace the middle thing with the red thing, which is what it's equal to. And this thing is equal to u of f of p. So we fixed p. P is any partition. So for every partition, LF of p is less than or equal to f of b minus f of a, which is less than or equal to u of p. That's for any partition. So now, that means that this is an upper bound for all the L of fp's. So since it's an upper bound, it's got to be less than or equal to, the supremum of the L of fp's. But a fancy name for that is just L of f. So L of f is less than or equal to this, and by a similar argument, this is going to be less than or equal to the infimum of all the u of f of p's, which equals u of f. But a fancy name for u of f and L of f are just the integral of f, since f is integrable. So the integral of f is less than or equal to this thing, which is less than or equal to the integral of f, so the integral of f has to equal that. And we're done. That's the first part of the fundamental theorem.